Hope it will not take long. So this is, I mean, just the like the introduction to a Brackenshaw model. So it's like the starting point of Brackenshaw model. So if you understand how the binomial tree model work, I think it will be much easier for you to understand how the Brackenshaw model works, because it's just, I mean, like the binomial is like the special case of the the Brackenshaw model is like the special case of the binomial tree model, right? So it's just, I mean, the way toward the Brackenshaw model, which we have to cover as the last part of this course. So this is actually what we have here. So we have risk neutral probability that the stock will go up in price and expected returns. So just 1 second here. All right, so just, I mean, a quick note here. Just quick. So this is not good. Yeah, so the risk neutral probability implies, okay, so the risk neutral probability that the stock will go up implies an expected return equal to risk-free rate if it is different from the probability of an up movement in the real world, right? So we are going to have two probabilities today. We are going to have the risk neutral probabilities, and we are going to have the real world probabilities. These two probabilities are not the same, right? So the risk neutral probability, I mean, apply in a different world, and the real world actually applies to the real world where we are living, right? So these are two probabilities which are completely different, but risk neutral probability are very useful, especially when it comes to pricing. So you'll see this, right? Mathematical finance in the future, or maybe like even actuarial science, you will come to realize how powerful this risk neutral measures your probabilities is when it comes to pricing derivatives, right? So let us move. So we have, I mean, two main parts here. Of course, we're going to see the binomial tree and how we can estimate the prices of option. So if you remember from the from week number 8, we have been assuming the prices of derivative were given, right? So I was saying, okay, let us maybe denote, let's say denote maybe, so we were using small p and then small c to denote the prices, right? So the put price and the call option prices, right? So that was the letters which we used to denote these prices, especially for European. But we are assuming these prices are given, right? So today we are going to see how we can find the prices of these options and of these options. So these are the learning objectives. So I don't want to spend a lot of time here because this is what we are going to cover. So we are going to assume, first of all, a one-period binomial tree, right? So I hope you remember from a binomial tree. I hope you remember from a binomial distribution, because the idea is from there, right? So it's something which is by. So of course we expect to have two outcomes here. So we either have something, I mean, goes up or something goes down, right? So that is what we have here. So you can see the price which we have here, for instance, is $20. So we're going to assume that this price, which is $20, can, okay, maybe like maybe in one day or 1 month, depending on the assumption. I mean, maybe tomorrow, maybe let's say this is today, and this here maybe is tomorrow, right? Tomorrow. So what is happening here is that, okay, today the price is 20, so we don't know what will happen tomorrow, right? So tomorrow the price can either go up, which is this part here, right? Your price can go down. We don't know what will happen, right? But it can either go up or go down, right? So we don't know that. So that is actually what we are going to cover here, and it's called a binomial because of these two outcomes, right? So price can either be up or down, and again with certain probabilities, right? So we're also going to think about probabilities. Yes, price can go up, but with what probability, or go down with what probabilities, right? So that is what we are going to see soon. So now let us start with this one period binomial tree. So one period meaning that we can either have, let's say, today and tomorrow, right? So we don't consider maybe the day after tomorrow. It's just one period. So the gap is one period, right? So let us focus here, and then later we'll see how we can extend from one period maybe to multiple periods, right? So let us use this example here. So we're going to assume, let's say you have the strike price, which is this one here, is 21, and then you have the time period, which is 0.25. And then, of course, you have the rate of interest. So the rate of interest, let's say, is actually 12. So here I'm going to use a number of like a number of notations. For now, I'm using S naught to denote the price today, right? So you move from today, which is S naught, but tomorrow, which is day one. So tomorrow, price can sorry. So tomorrow price can either go up. So I'm going to denote SU. So SU we denote the up price, and SD is going to denote the down price, right? So U for up and D for down, right? So that is what we are doing here, right? So then we are saying, okay, if we assume ST is equal to SU is equal to 22, for instance, then what is going to happen? Okay, so this is just like a simple assumption here we are making. We are saying, assume maybe the stock price at the maturity. So the maturity in this case here is capital T, right? But because we have just a single period, we are saying, okay, the maturity is simply SU. So when the price goes up, we just a single period. So the maturity price is simply equal to the upside, like that. So that is the first option. The second option, you can have the price at the maturity, this option here, where you have the price, is something which goes down. So go like that. So that is just an assumption. So of course, this is just because this is like your T, this is the starting point, which is T is equal to 0. So your capital T is here. So your capital T is T, is the same as SD or SU, so we just have a single binomial tree. So now what we are going to have here, again, I'm going to use another notation. So the first one was actually S, which is not the stock prices. So stock price, let's say you have stock price today, or you can have, maybe stock prices, let's say, no meeting, no recording, Catherine. So you can denote this by S naught. So S naught for stock, for price of stock today, or you can denote this one here by to use two notations here. Sorry. Oh, why is it not deleting? Okay. So the first one is is S. The first one is sorry. So the first one is S. Why this is so the first one is S for stock prices, and also I'm going to use F to denote the value of the of the derivative. So the value in this case here just means the payoff. Just ignore the cost, just focus on the payoff. So F will denote the payoff. Kwa hiyo kila stock price itakuwa na the associated payoff, depending on whether you have a call option or a put option. In this case here, we are assuming, let's say you have a call option. If we have a call option, we know the payoff is simply the difference between the stock price, the stock price at the maturity and the strike price. So you can see that I'm going to have F naught. But what is F naught? F naught is simply the maximum between the stock price and then minus what? Minus K, right? But so the F naught is actually the value, it's the payoff. In other words, it's like the value. So what we're interested here is that we want to understand what is the value of this option today. So I'm not going to estimate F naught because F naught is what I need. Because if I know the payoff, I can say this is simply the price which I have to charge for this. So this is, just ignore that. So nikishakuja this one here, when the price goes up, I know it's the maximum between ST minus K. So in this case, I'm going to have the maximum, sorry, comma 0. So I'm going to have ST in this case here is 22, and then minus K. So my K here is given is 21. So minus 21, comma 0. So when you do that, you're going to get the payoff in this case here is 1. So that is my FU. So when price goes up, I know the associated payoff will be $1, right? And then the other one is this one here, because we have the other option as well. Price can go down. So when the price goes down, we know the payoff will simply be equal to 0. Why? Because if you take the maximum of ST, my ST in this case here is 18. So if you take 18 and then minus K, so what is K in this case here is 21, and then comma 0. If you subtract this, you are going to get minus. So the maximum between minus number and 0 is 0, right? So we know the payoff, which is FP in the down scenario, is simply 0. So what happened now is that now I want to know what is the value of this stock today. So how am I going to do that? I need to like maybe now I need to find a way in which I'll be able now to get this. Given I know what is the payoff at the maturity, whether the price goes up or down, now what is going to be the value of this option today, which is actually the price in other words. So that is actually what I want to I want to cover here. So now let us move on. So okay, so in finding the prices, right? So here you can see, okay, I know this. I need what is F naught. This is what I need. I need what is F naught. I need the value of F naught. So there are different ways when it comes to pricing. So the problem here, which we want to do here, is simply pricing, right? So pricing. Now pricing kama mnafahamu ni, I mean, you are an actuary. Of course, we don't have derivative here, lakini I don't know kwa sababu tuweza kawa unafanya kazi kwenye market ambayo hata sio hii hapa, si ndio? Ndio maana we don't have to put boundaries kwamba okay, oh, we don't have derivative at BSE, then we don't need to cover derivative. I mean, it doesn't make any sense kwa sababu at the end of the day unaweza ushangaa unafanya kazi UK au unaenda unafanya kazi maybe Egypt or maybe South Africa, right? So because we don't know where you will end at the end of the day. So pricing is one of the rule of actuaries, sindio? So this is what we're interested here. We want to find out the price of the option. So what I'm going to do here now is that I'm going to show two approaches in which you can use to find the price of the derivative. Sindio? The first one is called no arbitrage. So the first one is based on the no arbitrage argument. Sorry, nimewasha fan, sio kama mnanisikia, ngoja ni turn it off. So just 1 second. Okay, so the first one I mean is no arbitrage argument. So no arbitrage, remember, kama mnakumbuka kuna wiki we discussed about no arbitrage argument, and then we said price yote ile, price ya derivative inatakiwa make sure kwamba haiko nje ya certain boundaries, kwa sababu kama price iko nje ya boundaries, then there is a probability for people to exploit that opportunity and make risk-free profit. Ndio kwa unapofanya pricing, you have to make sure that price in align na this argument, kwa sababu if it doesn't, then kuna wajanja ambao they will exploit that opportunity, sindio? And then of course they are going to make risk-free money. Sindio? So that is actually what we want to avoid here. So the first argument is actually using no arbitrage argument. So to use this argument, we are going to make this assumption here. So suppose, let's say you have a long position in let's say in delta units of assets. So this is just a unit tu ya za asset. Because like let's say you hold, let's say I can say let's say 2 units of maybe of CRDB stock or maybe of Vodacom stock. So no, because just the unit represent the units. Because you have certain units of stock. So what this means, okay, so this is the first thing. And the second thing in kwamba, suppose let's say you have a short position in one call option. So ndio, kwa this is your portfolio. Kwenye portfolio yako kuna asset. Kuna stock, sorry. You have stock. In this case here, asset ambayo nazungumzia hapa ni stock. So you have stock. Kwa sababu maybe una 2 stock, una 3 stock, it does not matter, right? But you have delta units of that stock. So ndio. And also in the same portfolio, you have, let's say, a call option, but you have a short position in that call option. So what is going to happen at the end of the day, at the maturity, this is what you are going to have. The value of that portfolio will be this one here. Why? Because we know we have a long position, because it's a positive, we have ST. So ST multiplied by the unit which you have. So in this case here is delta. So this is actually the value from the stock side. And remember, we have a short position in a call option. So this need to be negative. So that is why you can see here I'm using negative, because I have a short position. In in this. Oh, sorry, so 1 second. I think this is much better. And so you can see I have this one here. So I have this is the stock, and also I have this one. FT, remember, represent the value of the call option at the maturity. So that is F. But because I have a short position, then I'm using negative here, right? So this is the value of my portfolio at the maturity, si ndio? Lakini we have seen from the tree before, kama mnakumbuka, kwa sababu tulikuwa na tree ambao we started here with S note and then tukashow kwamba price can go up or can go down with certain probabilities, si ndio? So we can either have the up or sorry, the up or the down prices, which means the value of the portfolio again will depend on what scenario is going to happen at the maturity. So because the first scenario is this one here. At the maturity price inawezekana zikaenda juu. Tulimake assumption kwamba price ikienda juu, let's say zinaenda mpaka 22. So the value of my portfolio, I have to multiply here by 22, it will be simply delta multiplied by 22 and then subtract 1. So that will be the value of my portfolio at the maturity if the up scenario occurs. And then in the up and then subtract with the value in the upside, which is 1. And then I've done the same thing for the downside, right? For the downside, you can see the payoff is 0. Okay? So if you have any question, let me know. So again, post in the chat, I'll be able to see it. Or you can just unmute yourself and you can just ask that. So I'm able to see that. Yeah, so just 1 second. Okay, so so just want to make sure that everything is okay here. So okay, so that is the general idea on what we are trying to do here. Make sense? Yes, does that okay? But can we discuss marks? Can we discuss the marks? Are they you guys? Ameuliza maswali niko kwenye lecture. So that is the general idea, sindio? But remember here what we want in kwamba we want to make sure that there is no room for arbitrage. I mean, there is no room we can exploit the opportunity. So regardless of the outcome, we have to make sure that no room for arbitrage. So we are saying price can go up or can go down. Can we, what should we do so that at the end of the day, regardless of what happened, the payoff, I mean, just look the same. What should we do, right? So what we can do in kwamba, let us equate the outcomes in these two scenarios. So I'm going to equate this scenario and this scenario here. Sindio? Okay, so and I'm not subtracting the okay, so I have already used the strike price here. So let me take you back. Let me take you back here. So what I've done here ni kwamba I've said, maybe let me take you, where is the values? Is inaonekana vizuri guys here. So what I've done here ni kwamba I've said, you can have two scenarios. So you can have the up scenario, which is this one here. So FU, this is representing, I mean, the payoff. In other words, this is same as the value of this option, value of option. Then you compare kwamba, okay, find the price, of course, will be meaning the same thing. So find the price is like that. So this is what we did. So then we said, okay, to get this payoff, we know what is the payoff, FU. FU is the maximum between ST minus K and then comma 0, right? So my FU will be the maximum between what is ST? ST in this case is is 22, so the up scenario, and then my strike price, it was 21. So nika subtract 21 and then comma 0. Sindio? Comma, the payoff in this case here, you can see that is equal to 1. Sindio? So, and I mean, nimesha take into account the strike price already. Kwa sababu F ina represent the payoff. So we have already estimated the payoff or the value of the option, right? So what I was doing pale chini kwamba I was saying now, okay, we know the value of the payoff. Kwa sababu we are saying, okay, the value of the portfolio in general, we need how many units? So we had, I mean, the units of stock. So delta, this one here, and then minus the value. Why we subtracted this? Because we had a short position in a call option. So I'm saying in this case now, the value, if we want to substitute the numbers, they have to take delta multiplied by ST. ST is 22, and then subtract my FU. So FU is the value, right? The value of the option. But the value of option in this case here is 1 in the upside. So you can see this one here is actually 1. Right? Make sense? Anna, make sense? Bana ndio umeuliza swali. Okay. Yeah, so that is what we have done. I've already taken care of that. So the stock price is already included when we were computing this. So here what I was saying ni kwamba, remember the argument, no room for risk-free profit. So what I'm saying here that in order for me to be able to create a risk-free a portfolio, what should I do? I should make sure that regardless of the outcome at the end of the day, the outcome in the upside and the downside is just, I mean, the same. So I'm equating these two. Sabu, remember we have two options. Either price go up or price goes down. So I'm saying, what should we do so that at the end of the day, the outcome here and the outcome here does not matter? So I'm equating these two values in the upside and the downside, right? And of course, you can see when you do this and then you rearrange, you'll get delta is equal to that one here. So what this is telling you ni kwamba if you set delta is equal to 0.25, it does not matter whether price goes up or goes down, the outcome is the same. So there is no any room for someone to exploit any opportunity because I mean it does not matter. Right? What's the kwamba okay, I think I will gain when prices goes down. No, you cannot if we choose delta to be 0.25 because the outcome will be the same. Whether price goes up or price goes down, it does not matter. So delta represents the change. Okay, so now if you rearrange this, you can see that in this case, of course, if you hold 0.25 of the asset in your portfolio, then I mean it does not matter. Price goes up, price goes down, the outcome is the same. But if you look carefully how we have arrived here, you can see we are taking 1. So if you remember 1, it was FU, and then 0, it was FD, right? And this one here was SU, and this one here, it was SD. So it's like the change, right? So in other words, this is what we are saying here. This represents, I mean, the change in the call option price with respect to, I mean, to the stock price. So the derivative. So we can see that is FU minus FD, which is the value, right? So the value though is the same as the price. So it's changing the value divided by the change in the stock prices. So we can say that is simply, I mean, the derivative, right? I mean, delta C and delta S. So as you move on, you realize, okay, that is, I mean, that is a very powerful outcome, especially when it comes to hedging. But at when mbali sana, so that is the general idea. Kwamba delta at the end of the day represent the change in the price of an option divided by the change in the stock prices. I mean, what we have written here. Right? So is that because we're taking FU minus FD, which is a price or value, and then you're dividing with the stock prices. So make sense? Of course, we'll formalize this one here so that you will see how the formula look like. Make sense? So if you have any question, let me know. So now here what we are saying, okay, let us substitute the values. Sindio, kwa tushapata 0.25 ambao ni delta. Kwa substitute delta hapo, we'll see the outcome is the same here and here. So it does not matter whether price goes up or the outcome is 450. Is 450 regardless of what happened. I know the payoff is 450, right? So I don't know how we can create a strategy to exploit these two opportunities where price can go up or down. I mean, it does not matter. It's like there is no any uncertainty now here, right? Because I mean, regardless of what happened, the outcome will remain the same. So the portfolio, okay, so now we know what is the value of the portfolio here at the maturity, right? So we know the value of the portfolio is this one here, 450. But what we want, which is the value, we need this thing today, because at the end of the day, we will have to charge someone to be able to get this call option. So we need the price of this option today. So we are saying in this case, once you have obtained this value of the portfolio at the maturity, then to get the value of this portfolio today is very, very simple. How? Because you just need to discount this one here to today's values. So, somebody 450, then just so here now we just the time value of money stuff. So, someone like you just need to include the interest rate and just sorry, the risk-free interest rate in this case, and then just get the value of this option today. So that is actually what we are doing here now. So we are taking now, so we are saying, okay, to get the value today, we just need to take this 4.50 and then we have to discount it. So we can see we are simply taking 40, then we are multiplying by V. So we are multiplying by V power minus T because we want to discount this. So kukamla kumbuka first year, so you are 450. It's like we are not using this thing here. Why? Because I told you that this is not the discount factor here, because we are assuming that interest rate is compounded continuously. So when you have continuous compounded interest rate, the force of interest, then of course you just need 408 thing, this one here. So we proved this one, of course, before. Yeah, first year and now foundation this thing. I hope it's easy to remember that. Now that thing become very, very easy. And you can see that the price today is equal to this one. This is your F naught. This is the value of the stock today. So kwa hiyo so hatujaipata bado, si ndio? Hatujaipata bado, so this is the value, si ndio? This is the value, this is the value of the, sorry, this is the value. Okay, so this is the value of the portfolio in today's, in today's, sorry, it's not F naught, sorry. This is the value of the portfolio, in today's values. So what we have to do now ni kwamba tunafahamu. So let me write here. This was the value here. So this was the value for this one here. So we had ST and then minus FT. So we had this one here, and then we found that this one here is equal to this. So what do we have to do now? We have to discount this one here to today's value. But today's value, then what we are going to have delta S naught and then minus F naught, which will be equal to now 4, which will be equal to 4, which is good, will be equal to 4.50 and then E minus R, which we have there. Send 1, 2, and then minus multiplied by the T, which is 0.25. So now you can see that this is what we have here. Sindio, lakini we know this. Sindio, we know what is S naught, the stock price today, but we don't know what is F naught. Sindio, to get F naught, of course, we have to take everything to to this side, and then of course you just make F naught the subject there, and of course we'll get 0.63. Make sense? Does that make sense? What we are trying to do here? Hapo sasa nimewachanganya maybe. So any question? Does that make sense? So no response means everything makes sense. Okay, then I will move on, because the idea now is, okay, so this is what we have. We have seen how we can get F naught. So we just need to take the value of the portfolio in the future, then bring it back today. And why? Because we know S naught today. We know what is delta. Delta is already 0.25. But we don't know F naught, because F naught is the value of the option today. So we just need to rearrange everything and then get F naught, right? So that is actually what we have to do. So we can formalize this one here, right? Maybe like in terms of notations, and these are the formula kwenye vitabu over and over again, right? So remember that I said you start here, you start with S naught today. We are assuming binomial, so stock price can go up with certain probability, or they can go down with certain probability. Then we're noting the value by F naught, FU, FD, depending on whether prices goes up or down. And then what we are saying here, that we are saying we want to create a risk-free portfolio. So what are we going to do? We said, let us hold how many units? Delta unit of stock. But remember, stock can go up or down. So we are going to assume that from here, because we have to move from S naught to SU and then to SD. So we're going to make an assumption that for us to be able to move to this SU and SD, the value of SU and SD will be a multiple of a certain factor, let's say. So we are going to denote this. So SU, right? SU will be derived from S naught. So we're going to have a certain factor, which we call an up factor. So we're going to take the up factor and then multiply by S naught to get SU. And to get SD, we are going to have a factor which is called D, and then multiply by S naught, right? So you can see here, we'll be able to get SU as long as we know what is the U and the D factors, right? So this is what we are doing here. So I'm just doing the same thing. The value of my portfolio in the up scenario, remember, is SU, but SU now is US naught. So I just need to substitute here and then just get the value of the of the portfolio in the upside. And then of course in the downside, I have this one here. I've taken DS naught and then multiply by delta and then subtract this. So I'm just doing the same thing like what we did before. But now I'm saying, okay, how do I get SU? How do I get SD? It's simply by multiplying by certain factors. And if we do that, of course, we'll be able to get that. So then I'm saying, okay, I need a risk-free portfolio, right? So how are we going to do that? Let us equate the outcome. So when we equate the outcome, it means that if we have this deltas, which allow us to make the outcome the same, there is no any risk. So we know at the end of the day, the outcome is the same, right? So whether price goes up or goes down, it does not matter, because there is no any uncertainty in terms of outcome. The outcome, just remains the same. So you can see that we end up getting, delta is equal to this one here, right? So this is what we had before. So in this case here, I'm not using the values. I'm just using the notation where U and D denote the up and the down factors. So that is the starting point. And then of course, what we are doing here now, we are saying, okay, that is what we that is what we have. Cindy, this is actually the delta, and of course we know what will be the values of the portfolio at the maturity, but we need F naught, right? We need F naught, which is the value of the call option today. So we are saying we need to take the value of the portfolio at the maturity. Cindy, and which can either be this and this one here because they are the same, so it does not matter. Cindy, then we are saying let us take all this here, right, and then let us discount it to today. So we are saying, okay, this is the same as taking this or this one here and then just discounting to today's values, right? So I hope that makes sense. And now if you discount this today's values, now what is this? This will be the same as the value of the portfolio today, which is S naught, and then of course minus F naught, right? So this will be because we are discounting the value of the portfolio from the future to today, so that will simply be equal to the value of the portfolio today, right? Like that. So now you can rearrange because we need F naught. Sindio? Because if you do that, of course, we'll get either this one here or either this one here. Sindio? And of course, okay, simplify stuff. Of course, we'll end up getting F naught is the same as actually this one here. So kwenye vitabu vingi kwenye actual exam, kama unafanya actual exam, you will just come to find sasa kama kuna deviation ambayo iko I don't remember separately the new exams, but before I think it was not too detailed, but you'll be seeing the formulas like this one here. Kwamba, okay, if I want to find the value of the portfolio, sorry, if I want to find the value of the option today, what I have to do ni kwamba, first of all, I'm taking this one here, expected value. So I'm finding the discounted value of the expected payoff, right? Why? Because if we look here, this is like the weighting things, like you're doing the weighting. So look at the probability. So you have probability here, and then you have 1 minus P, right? Remember, P is a probability. Sindio? And FU and then FD. So it's like you are weighting something here with these probabilities. Sindio? And what is interesting is these probabilities, sio real world probabilities. These probabilities are estimated by taking ERT minus D divided by U minus T. So this is what we call risk neutral probabilities. Of course, you'll see, like in the next slide, isn't the risk neutral probabilities. These are artificial probabilities. They're not real world probabilities, right? And how do we compute them? We compute them by using this one here. Okay. So if you have all this information, then it's very easy to estimate the price of the option, right, which is F naught. So any question? if something does not make sense. Okay, seems like everything is okay. So now we are moving to the, kwa sababu I was in this part here, kama mnakumbuka, tulikuwa nazungumzia this one here, right? I was talking about the no arbitrage argument. So I hope mna follow that movement. So now what I want to do is that I want to move to the other argument. So tumeshaona kwamba if we use no arbitrage argument, kwamba there is no room for arbitrage. We can create a risk-free portfolio, right? Tumeona kwamba that can be done. So the issue now is, okay, let us now move to this one here, to the other approach. So the other approach is called risk-neutral valuation, right? So how does this work? Again, this is like I mean, it's like something which is hypothetical, but it's actually very, very powerful. Why? Because we'll see at the end of the day, the outcome from the no arbitrage argument, I'm going to make sense ideally, but you have to make sure that the portfolio which you have, I mean, there is only room for someone to make risk-free profits. So in risk-neutral probabilities, in this approach, so this is, I mean, it's like two people working on same problems, but using different approaches. But at the end of the day, they arrive at the same conclusion. So that is why this is very, very powerful. Yeah, so mkiendelea kusoma masters in actuary au ukifanya exam, kwa mfano ukifanya exam serious, sio ukifanya mbili afu ukaacha. So if you move on, you will just come to realize that this is a very powerful method. So what happened in this case ni kwamba we are assuming like a so hapa ni kama dunia tofauti kwa sababu sio dunia ambayo of course we live. So we assume a dunia ambayo I mean people it's like they don't care about risk. Ni kwamba if we want to make a decision about anything, so this is like they are indifferent to risk. So we are going to assume, I mean, like a world where investors are indifferent to risk. So I don't care much about risk. What happened ni kwamba ukiniambia kwamba okay, I can give you $100 in one year, right? Let's say in 1 year I'll give you $100. This is a sure thing, right? And ukinipa option ya pili ni kwamba I'll give you maybe $200 with let's say 50% chance, or maybe zero with 50% chance. So there is 50% chance naweza nikupa $200 au kuna 50% chance ya kupa zero, kwa hiyo nikakupa nisikupe. Naweza nikakupa kwa chance ni 50-50. Naweza nikakupa 200 au nisikupe. Si ndio? Kwa you can see in this case here ni kwamba ahadi ni the same, kwamba okay, so this ahadi is certain kwamba will give you 100 in 1 year. Lakini hapo you're saying okay, I will give you 200 but the chance is 50-50. Naweza nikakupa au nisikupe. Si ndio? You can see in the second option kuna some kind of uncertainty here involved. Si ndio? Lakini this part here ni sure thing. I mean there is no uncertainty. But in this world, a risk-neutral world, ni kwamba we assume that what we care is the expected payoff. I don't care about uncertainties. Kwa sababu ukiangalia hapa the payoff ni ngapi? The payoff ni 100. Nikiangalia hapa the payoff ni 200 multiplied by 50% plus 0 multiplied by 50%. Si ndio? The total here ni ngapi? Ni 100. Si ndio? In these two scenarios, the payoff ni the same. 100. Si ndio? Lakini scenario ya pili ina some kind of uncertainty. Si ndio? So what happened in this case ni kwamba we don't care about that uncertainty. As long as the expected payoff is the same, and these two scenarios, I'm going to value them in the same way. So this is what actually this means. So we are going to assume a risk-neutral world. And this case here, in kwamba investors believe that the asset growth, the risk-free rate, of course, I mean, we don't expect, I mean, any we don't care about risk in this case. We don't need any risky premium in this case. You don't care about that. So what happened in this case ni kwamba the expected return of every asset is risk-free, and the initial value of the asset is equal to the expected. Okay, so yeah, this is actually what I'm going to conclude maybe later. But we'll see how this work. It's like hypothetical thing. I'm going to use the same scenario. I'm going to assume, okay, let us assume you start here. So the stock price today is actually 20. And then this price can either go up or price can go down. si ndio? Kwa hiyo you have S naught is equal to 20 and then S up is equal to 22 or 8, just like what we did before. So we're going to assume that price can go up with P probability or they can go down with 1 minus P probability, right? So probability can either be P or 1 minus P. And then what I'm going to do ni kwamba I'm going to um okay, so here now is very important. So what I'm going to do ni kwamba I'm going to say, okay, if I have these probabilities, if I want to find the expected value of ST, so if I want to find the expected value of the stock price at the maturity, given that I have S naught, then this is very easy because the same was taking S naught and then you multiply by ERT, si ndio? Kwa sababu we are accumulating. So we are taking S naught and then we are multiplying that with the accumulation factor. But because we are assuming we have continuous compounding, then it's simply S naught multiplied by the accumulation factor, which is ERT, right? So we are taking that S naught to the future, right? So this one here is true. At the same time, I know the expectation because I know expected value of X. Sindio, how do we estimate it? We know that. Sindio, we have to take summation of X and then PX. So what I'm going to have here ni kwamba I'm saying, okay, this will be the same as, okay, so if you rearrange this one here, S naught will be simply the discounted value of the expected payoff. So if we divide na ERT, then it will be like that. Sindio? What will happen here? Ni kwamba we'll see now, I know what is expected value of ST. Kwa sababu if I have the probability, this is like the mean. Sindio? If I have P, then for me to get the expected value of ST, I have to take P multiplied by this plus 1 minus P multiplied by this one here. So I'm weighting this with the probability because I know the probabilities. Sindio? You can see that this is will give us this one here, this part. Sindio? So I don't know if this makes sense, but this is very, very powerful finding in this case. So here we're just making a note kwamba this S naught which we have here, this one here, I mean, is different from the real world probability. This is not the probability that the stock price will go up. It is not in the real world. I mean, it's something which is hypothetical. Sindio, kwa sababu I showed you that this P is estimated by taking ERT minus certain factors. So it's not real world probability for stock going up or down. Sindio, it's something which we have to compute mathematically because it's a hypothetical thing. So this just, I mean, a note here kwamba the real world actual probabilities of stock going up is different from the risk neutral probabilities. So these are different probabilities. So there, you can see here, I mean, S naught, of course, will be this. I mean, we are saying this M here will be the risk in the risk adjusted interest rate. Because in the real world, ukishaanza kutumia these probabilities, okay, maybe let me do like this one here. So what we typically do ni kwamba we so you want to put a plain area hapa ni just 1 second. So unless if there is any question, maybe. So assuming you are listening, mana the good thing about Zoom ni kwamba you just log in and then you just move on with your stuff. So assuming you are listening, so if you have any question, let me know. So what I'm saying here ni kwamba, so let me remove this thing here. Okay, so what I'm saying ni kwamba in the real world, kwamba nikisema kwamba chukua P and then multiply by SU and then let's say plus 1 minus P and then let's say SD, si ndio? These probabilities kama nilivyosema ni kwamba they are different from the real world. So most of the time you'll find in the like in books when it comes to risk neutral probabilities wanakuambia kwamba this is the same as like saying price today is the same as taking the expected discounted value. So let's say 1 over 1 plus R kama wanatumia tu I mean interest rate ya kawaida ambayo is not continuous compounded inakuwa EQ and then price tomorrow. Price tomorrow. So what this is saying ni kwamba, okay, mathematically this is how we write. So we say, okay, if I want to find the price today, I have to take the discounted expected payoff tomorrow. Sorry, this is tomorrow. expected discounted price tomorrow. Si ndio? Discounted expected price tomorrow, which is computed by taking this one here. And kwa sababu ni risk neutral, we are doing this discounting by this risk free. But we are noting that this is different from the real world probabilities. Kwa hiyo, in the real world, price today, I mean, it will be something like 1 plus 1 plus R. Like in this R, because some people are risk averse. So if they want to take more risk, they need compensation to that. So this will be adjusted rate, not the risk-free rate. At the same time, I will not write like this one here. So most of the time, I will write this like P to differentiate between Q and P, because Q need risk neutral probabilities. So I'm saying, okay, I'm going to estimate this expectation under risk neutral probabilities. So I'm going to estimate under the real world probabilities, right? So that is actually what I wanted to note in that part. So this is actually what this part here is talking about. We have to make sure that we differentiate the risk neutral probabilities and the real world probabilities, right? So again, this is very, very simple. So I'm doing math, and then of course we'll generalize this formula. So you can see here we're saying, okay, if I want to find the expected value of the stock at the maturity, I just need to take the price today and then accumulate it, right? Which is the same as doing what? This is the same as taking, because I know what is the expected value of T. This is simply the weighting. So I can take the weighting here because I know the scenarios. I have the up and the down and the corresponding probabilities. So I can weigh them, and then this will be equal to S naught ERT. And then even for the value of the portfolio, because if I know the value of the portfolio today, then I can get the future one by simply taking F naught and then accumulate it to the future scenario, which will be the same as taking the expectation. So I know the FU, I know the corresponding probabilities, I know this one here and the corresponding probability. So I just adjust for that, and then I simply get this one here scenario. So now it's become very, very simple because we have all the values. So if you rearrange this part here, if you substitute the value and then you rearrange that, you'll end up getting P is equal to around this value here. So once you get P now, it's actually very, very easy. Why? Because once I know my P here, the issue is, okay, so what is F? Because the value or the price of the option in this case is F. So I did now to rearrange in such a way that I end up getting F naught. So how am I going to do that? I have to divide by ET. So this is what we are doing here. So this is the ET, and then this one here. In other words, what I'm doing that I'm just, discounting, right? I'm just discounting the expected payoff at the maturity, so that I'm actually able to get the value of the portfolio today. So the same thing, I'm saying, okay, in order for me to get F naught today, I have to find the discounted value of the expected payoff at the maturity. Payoff, sorry, this is payoff, one payoff. So F naught is simply the expected value of the payoff at the maturity. So we are discounting that. Because another language used over and over again, the price of a derivative is the discounted expected payoff at the maturity. This is actually what we are doing here. So you can see, if we do that, we end up getting the price of this one here, which is the same like what we get in the first argument, which was no arbitrage argument. So now let us formalize this one here in notation form, so that is easy maybe to compare with what we had before. So you can see I'm just using the same thing here, F naught, and then you can see I'm expanding this and no expectation how to compute it, and no. So once you do that, you'll rearrange it, you'll end up getting this, because I know the up factor is this one here, the down factor is this one here. So price goes up with up factor, goes down with down factor. So if I know S naught, I can get the SU, I can get SD. So this is what we are doing here. Then of course, you'll see that once you rearrange that, your P will be equal to that. And then, of course, your F naught will be this one here. So if you look at this one carefully, that we end up getting the same thing. We end up showing that the value of the option under the risk neutral valuation and no arbitrage argument, they're actually the same. So if the risk in, if the no arbitrage argument makes sense to you, then the risk neutral valuation makes sense to you. Although we make all these hypothetical assumptions where investors are indifferent to risk, that should make sense to you, because we end up getting the same thing anyway. So that is why you will see that valuation, that derivative, CO2 derivative, of course, you will see, I mean, most pricing problems, they will simply go straight forward to risk neutral valuation because they know at the end of the day, you end up getting the same thing with no arbitrage argument. And we said before that when setting prices, you have to make sure that the price does not allow people to make risk-free profit. So that is why this risk neutral valuation is actually very, very powerful method when it comes to pricing, and especially when it comes to pricing derivatives. So as long as kama utafanya in-short ile, you will come across this stuff. So you cannot run away from this stuff anyway. So at some point you will come across this stuff. So they're very interesting, I think. So any question? Make sense? Make sense or not? Yeah, so this is the problem of teaching Africans online. So it's like teaching is clean. So okay, thank you, Anna, and thank you, Ben Patrick, and Sharon as well. So now just move to the other part because I've been saying that okay, price can go up. So we can have maybe let's use this one here because I've been saying this here. I've been saying, oh, we start from here. Uh, so I've been saying, oh, we start from here, and then price can go um, up or can go down. So, and I said, okay, we can estimate SU and SD from West North. And I said, how? I mean, by taking this one here, and then you take U, and then of course, sorry, D, and then S North. So the question is, how do we estimate this U, and then how do we estimate this D? Because once we have that, then it's very, very easy for us to get, I mean, the price in the upside and the price in the downside as well. So that is actually what I actually wanted to cover now here. So how do we estimate the U and V? So people did this long time ago. You can see, I mean, the years here. See there? You can see the years. 1979, the people were thinking about this thing. Kwa sababu nadhani, yeah. So I think pricing of these derivatives, they take they take off, I think, generally 1970s. So for us, I mean, we are covering this, ndio, lakini watu walianza kufikiria this in 1970s anyway. Hata ukiangalia the paper which I'm going to show you next week about the Brackenshaw model ni paper ya 1970 na ndio kwa watu wanaanza kufikiria this thing. Kwa hiyo this method was developed by Cox, by Ross and Rubes. I don't know how to pronounce this, but it looks like Epstein. Um, so is a Jew. Si ndio haya majina ambayo anaishia Stein, like Albert Einstein, um, like this one here, like Epstein. I mean, all these are Jews. So, Ko is a Jew. So, I mean, that's not matter anyway. But yeah, so they did that. So they came up with the up factor and then the down factor. I don't care how they arrived at this point. So we're going to assume that is actually what we have to do to get the upside. So you can see what is interesting here is that the upside or the downside depend on one parameter, which is very, very important, and that parameter is delta here. So this is the volatility, right? So volatility, I mean, play a crucial role in determining the up factor and the down factor. And we know that makes sense, right? Let me, okay, so I can explain maybe here. So I'll just checking something here. So yeah, let me explain maybe here, okay? So you can see the way we are computing this. We are computing it a very easy way. So we are saying, oh, the up factor is simply E sigma, and then of course, these time steps. But we have one key thing here is volatility. So volatility, I mean, is like, so the one which is adjusting the angle. Why? Because we are saying this is like this. Okay, so we are saying that prices can either go up or prices can go down, right? Like that. And they go up with certain fact with volatility and then multiply by the time step. So if I mean volatility is small, you expect this angle to be small as well. Sindio? Or maybe it will be like this. But I mean, when this one here is large, you should expect that angle to be large. So you'll see that price is going up like this. Sindio? Na ikiwa kubwa zaidi, then you'll see, I mean, this will go, the movement will be, I mean, high. Sindio? Ko the higher that parameter, the higher the volatility, I mean, it means that the angle will be small and then that angle will keep on increasing and then of course increasing and then of course increasing. So it's very interesting that the upside depend on the volatility. So here you'll have low prices, here you'll have high prices, maybe here you'll have very high prices, depending on the volatility parameter. So that is how you can compute this up and the down factors. So as long as you have all this information, then of course you can get everything which you need and you can price the 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 derivative. Okay, so this is like, I mean, a two-step binomial, because what I've been showing you ni kwamba just a single period. Kwa na assume kwamba you are today, so today the price is here and then tomorrow is here. So you have just, I mean, one period. You can see the gap will just move from t is equal to 0 to t is equal to 1. So we are saying, can you extend this to 2 is equal to 2? So here we are saying, okay, we can move this to t is equal to 2. So like that. So t is equal to 0 to t is equal to 1 and then t is equal to 2. Si ndio? Kwa maana ukishakuja hapa tena utaona kwamba this will again move up and down and then this part you are going to have movement up and down. Si ndio? But in this binomial tree we are making assumption kwamba in case iki move, I mean this outcome will be the same. Kwa sababu hii ni kama this will go up after up and then this will go down after down. Si ndio? But when it goes up and then down, and then or maybe down and up, of course, the outcome will be the same under the two scenarios, right? I will explain. So of course, you can see, I mean, it's very, very easy now because we can get all the values. Sindio? We have all the information, so we can estimate what is the up factor, what is the down factor. We can estimate the probabilities because we need this in order for us to be able to value or to find the value of the value of the option. So if you start with the price, which is 20 here, you can see the up factor is this one here. So if I take 20, so if I take 20 multiplied by this up factor, 1.1213, I will get this one here. If I take this 20 and then multiply by the down factor, I will get this one here. And if I take, again, if to get this one here, I just take this here again, then multiply by the up factor again, which is 1.1213, I get this. To get the down factor, I take this value, multiply by this. Is very, very easy. So once you know these two values here, the down factor and the up factor, you just start from S naught, which is this one here. To get the SU, you simply take S naught multiplied by the up factor. To get SC down, you just take S naught multiplied by the down factor. Or you can try. You see, I mean, this is very, very easy. And then of course you can see that once you multiply by this one here again, once you take, because this is going up. Maybe let me show you. So what is happening hapa ni kwamba this is my tree. I start here. Price inaenda juu au chini. Sindio? Let's say you start from 20. Sindio? To get the value of hapa ndachukua 20 multiplied by the up factor. What is the up factor? The up factor is 12, 13. So I will multiply with 1.1213. I'll get here. Sindio? What is the down factor? The down factor is 0.8918. So down factor, so 20 multiplied by 0.8918, yeah, like that. So it will give me the value here. So this is one period. Kama ni two period, manake I will extend then here and here. Sindio? Ko again tachukua hii ni up. Sindio? Ko I will take the value which I had here, multiplied by the up factor again to get here. To get the down here, I will take this value multiplied by the down factor. So it's like that. So it's very, very easy to do this. And then you move on and on and on. Or you can construct the tree as long as you have all the, you just have the U and the D and the stock price, the initial stock price. You'll get an idea of how this is going to look like. All right, so this is what we have done to get this tree here. Yeah. And then of course, what I'm doing next ni kwamba, remember ili niweze kupata price, ili niweze kupata price of an option, I also need the value of the option. So what I'm doing here ni kwamba, I'm trying now to estimate the value of the option. So how do I estimate the value of the option? I estimate the value of the option by, so remember this is for the stock price. So we already know the stock prices, si ndio? Tumeshabana the stock prices in the two-time period. Kwa sababu time period inaanzia hapa. So this is t is equal to 0, and then this one here is t is equal to 1, and then this one here is t is equal to 2. Si ndio? Kwa hiyo this one is 2 period 3. So now what I'm going to do ni kwamba I need now to find the f, which is actually the value of the options. So how do we do that? The idea is the same. This is what we need at the end of the day. Like in FU, how do we get FU? We get FU by taking the maximum between ST, kwa sababu ni call, minus K, comma 0. So what do I need to do? I have to take kona angalia FU. What is FU? The price is this one here. So just take 22.43, subtract with the strike price, which is 21, and then of course, comma 0. So, comma 0. So what am I going to get? What am I going to get here? Comma 0. Sorry, I don't know why this inakuwa inaenlarge unnecessarily. Okay, so that is the general idea. Kwamba that comma 0, of course, I'll get the value at this point, and then of course I do the same thing. I get the value here, and then this and this one here. So easier for you to ni notation kwa sababu I can simply write like this one here. I can simply write like this. So I have S naught here, I have SU, I have SD. So nikitengeneza tree nyingine hapa ni kwamba what I'm doing ni kwamba, remember I started from this is SU. This is again nilianzia kwenye SU but nimeenda tena U. Si ndio? Nikija hapa ni kwamba I started at SU lakini tree imeenda down. Si ndio? Nikija hapa maana ni SD lakini imeenda up, and then of course here ni S down and then S down. It's just notation. Waweza kawa una nyingine ikawa SU, so depending on the step which you have in your tree. Kwa notation too. What I've done here ni kwamba nimestimate the prices, which is the left, and the right is actually the values. So now to find the value, which is F naught, is very, very easy. So what I'm going to do ni kwamba, once I know this one here, the idea is very simple. Kwa sababu I know okay, so I'm trying to align with what we have here. I think what we end up with the same answer anyway. But okay, this one ilikuwa limetoa nini? Ilikuwa limetoa t is equal to 6 over 12, and then we had 2 times step, and then of course we have, okay, so sorry. So your strike price, your strike price and strike price at the maturity, so you cannot apply it here. Sorry, the strike price was supposed to be applied here. I hope makes sense. Kwa sababu sorry, niliassume kama ni single tree. It's not a single tree, si ndio? Hii ni two-step tree. Kwa you can see manake the strike price will be applicable at this point here. So this is where I have my K is equal to $21. So what happened now ni kwamba I can find all the payoff. I can find FUU, FUD, and FDD, si ndio? So now the question is, how do I get this one here and how do I get this one here? Because at the end of the day, what we need is actually this F naught. Because then it becomes very, very easy. Why? Because I know the probability here, P and 1 minus P. So now what we can do, we can say, okay, if I want to get FU here, FU is simply the discounted, ERT, the discounted expected payoff. Payoff. Like what we said before. So this is what we are doing here. So we are discounting the expected payoff. I'm taking this 4.15 multiplied with the probability, and then 1 minus this number, you get this, and then multiply by the payoff here, which is actually 0. I'm combining these two outcomes here to get the values here. And then to get the value for here, I'm combining these two values here to get the values here. Because FD, again, will be the expected payoff under the down scenario here. So you can see that I'm taking, so my FD will simply be 0, and the probability here, and then 0 and the probability here. So you can see at the end of the day, I end up getting 0 because the two outcomes are 0 in that cases. And then I discount everything. So I end up getting FU and FD. So once you get the FU and FD, it means that you are here. Kwa ukishapata FU and FD, it means that ushapata values za hapa na values za hapa. You can see the value ya hapa ni 2.43 and value ya hapa ni 0. Sindio? Kwa to get the value ya hapa pia ni the same thing. Kwa sababu I know F naught again is the same thing. Ni RT expected payoff, I mean, one period from 0. Sindio? Kwa I just need to combine this and then take it here. Because this is what I'm doing here. This is the discounted value, and then I'm taking the outcome here, which is the probability, and then multiply by 4, 3, and then this multiply by 0. I don't know if I'm simplifying this, but I think it makes sense. I'm just going back. Kwa nimetoka huku. Sababu I know these values here. All these values are known. Because the question is how do we get this first of all? We get this by taking the expected, by discounting the expected payoff to get here, and then you take this, take it here, and then to get here, you just combine these two outcome. I mean, they'll take you here. Does it make sense? Okay, thank you, Sharon and Gulam. Okay, so should we take 2 minutes break?
Yes.
Okay, yeah. So let us take how many minutes? Let us take like 3 minutes. So again, drink some water and then you can come back. Okay, so I think we can continue now. Yeah, so let us now move from here because what we needed is actually to get the value of the value of the option here. Um, so okay, so yeah, so this was for call option. So I don't think if we just need to waste time again because the idea is the same. So remember this was the call option. So the only difference between a call and a put option, I mean, is simply here. Because in the call option, the payoff for the maturity will simply be equal to the maximum between ST and K, right? But for the put again, is the opposite, which is K minus ST. So the payoff will look, I mean, a bit different. But otherwise, I mean, the approach and everything which we have done will remain the same. So in case of match period for the put, the idea is just like what we have done. Okay, so yeah. So that said, unless if there is any question, because what we have been assuming here, we have been assuming that we have a European option. Hii ni kuonyesha kwamba ilikuwa ni European option. Kama nakumbuka kwamba American options allows you to exercise your right at any point, si ndio? Kwa you don't need to wait until maturity, si ndio? Kwa you can see idea ambayo nimeitumia hapa ni European kwa sababu na assume kwamba I mean everything is here, I mean is until the maturity, si ndio? Kwa hiyo this will be a bit different now from American. Kwa I want to move to Americans here. So we are done with that. So I think is so this one here. So American options. So the way we price this, and here of course we're using put just an example. So kama kuna hata ni yote ambayo specific, I mean you can use call, I mean it does not matter. So let us see now how we can use American options. And by the way, binomial tree, I mean, is the only method you can use to find the price of the American options. Of course, we have Brackenshaw model, I mean, which is very powerful, but Brackenshaw model is very helpful when you want to find the price of the European, but when it comes to American, of course, we'll come here. Of course, we have some approximation, but I think binomial is very powerful when it comes to Americans. And you'll see the reason why. So you can see the idea. So the idea is the same. The way we construct the tree is just the same. What we have changed here ni kwamba we are assuming that you can exercise your right at any point. You don't need to wait till the maturity. So the way we find the value here at time zero is by, so let me explain here. So I will start by finding what is FU and then what is FT, right? Then, okay, so the way we estimate this is by noting the idea that for American options, you can exercise your right at any point. You don't have to wait until maturity, right? So what I'm doing here ni kwamba I will start asking myself, okay, is it optimal to exercise my right here or is not? So the payoff here, right? The payoff here is not simply the discounted value like what we have done before. So before tunachukua hii outcome na hii outcome, and then we multiply with the probabilities, and then we discount it, and then we get, I mean, the values here. So that is what we did for American options, but for Americans now, we'll have to ask ourselves, is it optimal to exercise here? So how? You can see the way I'm doing this one here. So I'm asking myself kwanza. So I'm finding the discounted value like what we did before, ambao ni this part here. Hii ndio part ambayo tulifanya mwanzo. Tulichukua hizi outcome mbili ambao ni 0 na 2, tukaziweight na probability na tukazi discount. Kwa hiyo tukapata hapa. So tukapata value ngapi? Kama mnakumbuka tulipata 3.51. Si ndio? Then tuka move on. But in American, you don't have to move on. You have to ask yourself, because there is also the possibility for you to exercise at that point without going to maturity. So I have to ask you, okay, what is the payoff here again? If I just exercise everything here. So here I know, kwa sababu input market itakuwa ni maximum ya K minus ST. So what is K? K is 22, call 22, and then subtract what is strike price. Strike price, remember, sorry, stock price in 22, put 43, si ndio? Kwa hiyo ukitoa hapo you get negative. Cogens, oh, nimekosea. What is the ni sawa, sio? Yeah, is 0. No. Ni FU, yeah, ni 0. Asema nimekosea copy number, sio? So what I'm saying ni kwamba FU ni this one here. Si ndio? Kwa sababu hii hapa ni patch ambayo tulifanya last time kama mnakumbuka. Si ndio? We just combined the two outcomes ambao ni this one here and this one here with the probabilities ambao ni this, and then we discounted it back, and then we got, I mean, the value for here. So now what I'm saying ni kwamba ukishafika kwenye American una two things. The first one ni value uliyoipata mwanzo ambao ni 0.77. Si ndio? And then the second one ni kwamba unaweza uka exercise your right here immediately bila kwenda kwenye maturity kwa sababu you have that option in American. So what I'm saying here ni kwamba if we exercise this immediately here, how much are you going to make? So you'll get maximum of X of k is 22, subtract, si ndio? Hili hapa nikosea kuandika ni sawa, ni 22.43, si ndio? The maximum here is actually 0 and 0. So you get 0. Una two outcomes here. Moja ni outcome ambao you will get if you exercise at that point, which is 0. And the second outcome ni this one here. Kwenye America ni utaangalia okay, ni exercise at this point napata 0, si ndio? Maybe I have to wait until maturity. Because there is no any point ya exercise at this point wakati the payoff is 0 while you can wait until maturity and get something. That is why we'll see I'm saying, okay, I will look at the maximum between what I have if I wait until maturity and what I get when I exercise this immediately. And then I do the same thing here kama mnakumbuka. So before we said, okay, let us combine these two things with the probability and then discount them back. So we had this part here in the downside. Sindio, ambapo the value ilikuwa ni ngapi? Ilikuwa ni 4.16. Sindio? Here I know kama nikiwait until maturity I will get 4.16 in the current values according to that point, but ni exercise immediately I will get maximum ya 22 na 22 point, sorry, 22 minus 17.84. Ukitoa hapo unapata 4.16. 4.16, sorry, hii before ilikuwa ni sorry kama na confuse, ni this one here. Na ni mwanzo ilikuwa ni 3.51. Nikiwait until maturity I just get, exercise immediately I just get this one here, 4.16. So you ask yourself, what is the maximum between the two? Should I exercise my right immediately or should I wait until maturity? Sindio? You can see you take the maximum. Because there is a possibility for you to actually not wait until the end of your contract and just exercise your right at any point. So we have to check which one is the maximum, waiting or doing that immediately, right? And then ukishafanya hivyo manake you are done, kwa sababu manake utakuwa una outcome now, si ndio? Utakuwa una outcome ya hapa na outcome ya hapa ambao you have compared, you have picked the optimal options. Lakini bado is not the end. Hata ukifika hapa pia you have to check. I will check, okay, should I wait for 1 month or 1 year? Okay, should I wait, which is this option here? If you wait, you'll have this one here. You'll get 2.50. But if you exercise immediately, then manake hapa pia unaweza ukafanya exercise. Manake you have the difference here, which is K is 22. K is 22. So 22 and then minus 22 minus here the stock price is 20. So minus 20, so get 20. So you can see that you can have 2 if you exercise immediately, right? But the maximum you can see is actually 2.05. Right? So it's worth them to wait and not exercise immediately. So this is actually your F naught. I'm not sure if this makes sense. The difference, the way we are implementing this, right? Kwa sababu kwenye European is very, very easy. Kwenye European ni straightforward. Kwa sababu everything ni until maturity. So you just have to wait everything up to this point. So I have to wait until this point. So but then when of course you have option to exercise early, you have to compare whether it is optimal for you to do that thing immediately or whether you have to wait until maturity. So that is the main idea here. So make sense? Or you have any question maybe? Any question? Okay, so I hope that makes sense. It's very simple ideas. So we'll see. So here what I want to do ni kwamba this is just the motivation of what we are going to do next week. So next week here, of course, we'll have one lecture. It's very short lecture, by the way. Ningeweza kumalizia sasa hivi lakini I think kuna other stuff we have to do. So but it's very, very short lecture. Kwa itachukua tu muda mchache to finalize everything. But it's just the motivation now. Why? Kwa sababu you can see hapa I have to pick the time steps. Sio kama mmeona hapa kwenye computation. Kwenye computation hapa I'm using delta t. So delta t is like the change in time, sio? Just take the time kwa mfano kama hapa time tulipewa 6 months, si ndio? You can see the time kwa mfano kwenye hili swali ilikuwa ni 6 months, ambayo ilikuwa ni t is equal to 6 over 12. No, this is t, sorry. Okay, so we were given t is equal to 6/12. So nikuandikia this change in t, hizi ni time step. Kwa maana what happen hapa ni kwamba this is the same as taking this. Kwa unaangalia time step ngapi? Kwa unaigawa ile time kulingana na time step ambazo unazo. Kwa kama ni mbili kama hapa, maana you just divide this by 2 ambao unapata change in t will be equal to 3 divided by 12 which is actually 0.25 ambao tumeitumia kama change in t. So that is the general idea behind this one here in case it's confusing you. Serio. Once you do that, of course, you'll get your price of the option, which is F naught. So what actually I wanted to show in this plot here is like the motivation for what we'll do next. Kwamba here we are trying to plot the option price, and here we have the number of steps. So this number of steps, of course, ni n, kwa sababu unasema kwamba t is equal to, you just take your change in t is equal to capital T, and then you divide this by n. So n is the number of step. Kwa hiyo kwa mfano kama ni this one here, your n is 1 kwa sababu ni just one step. Kama umeenda za pili maana hii ni n. Kama umeenda tatu maana yake ni 3, si ndio? Kwa the tree will just go on growing like that, si ndio? Kwa this is the n which we have plotted here. So this is my n, and this one here is the call option price. So it can either be C or it can be P, depending on whether you have a put or you have a call option. Si ndio? But you can see what is interesting in this figure ni kwamba, I mean, the more the number of steps you have, right, you can see like you are converging somewhere. Kwa unavyoongeza number of steps, you can see the option price, option value in a converge, right? You can see, I mean, this is like at the end of the day, it converges here around this. So you can see the price in a converge here. Si ndio? Kwa you can see, unapoanza na step ndogo, maybe the price is here. Ukiongeza step, you get here. But the more the step you have, you can see you are converging to a single value. And this is actually where now the idea of Brackenshaw model comes, because they said, okay, it seems like we can just end up with a single value here. So if we take the if we take more steps, then we can come up with something which is maybe which will give us, I mean, a more reliable price in this case, right? Because the more the step you have, you just have a convergence. Ni kama tulivyokuwa tuna zile force of interest kwenye introduction to actuarial studies. I mean, you have I mean, you have monthly, you have yearly compounding, sindio? You have yearly compounding, you have daily compounding, you have that. So the more you do frequent compounding, you're talking about, oh, I'm converging to a certain value, right? At the end of the day, I just end up with a certain rate of interest. I mean, converging somewhere, or approaching, I mean, certain number. So this is actually the motivation behind this one here. So it will converge a certain value here, right? So it's a very powerful method, by the way. So if you want more accurate answer, you have to, I mean, use more steps, right? Maybe 30, which is typically used in practice. So huku now I will not actually, I don't care much because the idea is the same here. So before to assume kwamba, suppose you have an option and the underlying asset is a stock, but the stock does not pay dividend, right? So you can say, okay, maybe that is not realistic because in reality, you'll have many stocks which are paying dividend. Of course, we have a number of stocks which does not pay dividend, so this assumption can work. But in case if you have a stock which does not, which pays dividend, then of course you'll have to adjust that. So you can see here, the adjustment is simply in this part here, right? So I'm adjusting the stock. So I'm adjusting the stock here. I'm not adjusting here. Kwa sababu kama una own option, I mean, you're not entitled to I mean, you're not entitled to receiving that, unless if you are holding the stock. But this is the option. So I'm not adjusting here in case of option. So you can see I'm doing adjustment here because I know if I have a stock, then I will have to receive the dividend. Na kama mnakumbuka, kwa sababu hapa ni kama return. So return inakuwa affected by decreasing. Return inaenda chini. Kwa this one here is actually a dividend. Kama nakumbuka mwanzo tulitumia dividend ikasema kama unachukua stock price minus D. Hizi ni discrete. Lakini ukumbuke kwamba hii hapa is like supposed to kama ni return, si ndio? So if it's the return, then what is happening hapo ni kwamba that is continuously compounded. Kwa kama ni continuously compounded, you need the rate also which is continuously compounded. Kwa tunashumu pia dividend inakuwa paid on a continuous basis. So whether the assumption is robust or not, that is discussion for another day. But that is actually what is going to happen. That is the only change, because you can see what will be affected in this probability here, the way you compute the P. But you can see the way we are combining the payoff, because they're not affected, is simply the same thing, like in the same way, right? So that is yeah. So here I'm just doing the deviation like what we did before, so you can see that everything is just the same. I'm repeating the same thing, and then I think at the end of the day I just wanted to it's just so the difference is simply in this part here and then this part here, right? So let me stop here. Unless if you have any question, maybe, which I'm happy to take, but let me stop here. And next week, we'll just finalize with the Brackenshaw model. So the Brackenshaw model is very short lecture, so it will take around maybe 1 hour, and then I think we'll be done with everything. So unless if you have any question, I'm happy to take that now. Any question? Okay, if there is no question, then thank you for coming. And yeah, so we have to do the quiz. Sorry, we have to do the quiz. So I don't know how this should work. Yeah. So on Tuesday, I'll not be able to come to the class. Labda maybe nimwombe mtu anisaidie labda kuinvigilate the quiz. So the quiz will be 30 minutes, I think. Yeah. Aspera, maybe kama you have any comment. I hope you are around.
I do not have any comments. But
Okay. So either
can we discuss about that Tuesday quiz? Is it
okay.
negotiable
With me? Nye?
with you?
Okay, yeah. Yeah, it's fine, yeah. Yes. So I'm listening.
Can we have it another time, not the same Tuesday?
Yeah, it's fine. It's fine. Anytime. What about we? It's fine.
Okay.
Any time. Kwa sababu ni 30 minutes. The 30 minutes quiz. I think even the marking. Uh, yeah. So Oscar, the issue is the issue is nahisi nitapata lawama kwa sababu kwa watu wasio kasema kwamba walikuwa hawana resources za kufanya exam online. Kwa ningekuwa na muda wa kufanya some testing ningefanya before, lakini sasa hivi watu wasikaanza kulaumu. Like me, I'm okay with either option. With either option. If you agree, just let me know if you agree kwamba you want to do this online. I'll just set a quiz online kwa sababu ni muda mfupi. So I'll set this online and then you can do that thing online. But yeah, kwa sababu ingekuwa kama chuo kina special venues ambazo zina access kama zina laptop ziko, people can simply go and do that there, ikuwa fine. Sasa hivi hata sifahamu mna resources gani sasa, kwa sababu if you have laptop is fine, lakini kuna watu I hope watasema wana resources, so I don't want that lawama, lakini if you are okay with that I can set that. Sawa, Spera na Oscar wamesema.
So I
So
think most
just
of
let
us
me know,
wanna lap.
Spera, so you can do it.
Yeah, we can have it online.
Okay, so itabaki nani? Itabaki ule nani? Yeah, so I'm done. I'm discussing this Spera. Spera atawapa feedback. So if you want to go now, it's fine. I'm saying kwa atabaki nani? Atabaki